Hi viewers, and today I am going to teach about the concept Biot Savart law. So Biot and Savart are two scientists. They have done an experiment regarding that force experienced by the magnet when the magnet is kept nearly close to the current carrying wire. So they did that experiment. They take one current carrying wire, and due to the current is flowing inside the conducting wire, it experiences some force. So it exerts some force on a magnet, and those magnet experience some force. So due to this current, it exerts some force on this magnet, and this magnet is experience some magnetic field. It experience some force. It experience some force due to the current. So mathematically they proved this experiment, and what those things we're going to see now. So they take a current carrying wire, that is the current carrying wire. It is connect with the battery. When the connection is connect with the battery, when the conductor connect with the battery, it start to produce some electricity. That means current is produced due to the potential difference. We know that the current is flow from higher potential area to lower potential area. Okay, then in this current carrying wire, the total length of the current carrying wire is L, but we are taking the small elemental length which is perpendicular. Here we are taking small elemental length of the conducting wire which is perpendicular to the wire. So here we are take one small magnet which is nearly close to the current carrying wire. So when we kept the magnet is here, due to the current flow inside the small elemental area, it exerts some force on this magnet. Due to the exerting of force, this magnet experiences some force. It exerts some force. The magnet also experiences some force due to this current on the small elemental length dl. So how much force is exerted and how much the magnet is experience the force and how much magnetic field is produced, that only they have derived mathematically in this Biot-Savart experiment. So the small elemental length dl, and here we are kept the magnet at point P. So the distance between those 2 points is R, and R cap is what direction force is experienced and what direction force is exerted due to this current. So here from this dl to P, only the current is the force is exerted and force also experienced. So the direction is indicated by the symbol R cap. So R cap, you know that it is indicating the direction of exerting force or experiencing force. So after this experiment, after the magnetic the force is experienced by the magnet at point P, that is directly proportional to, so the magnetic force is experienced by the magnet is directly proportional to the product of current carrying wire and the small elemental length, because the current is flowing here perpendicularly to the small elemental area. This is the current I flowing perpendicularly to the small elemental area. So both the things are mutually perpendicular, and the force, the magnetic force experienced by the magnet dp, that is directly proportional to the product of those perpendicular product of current and the small elemental area. And here in the sin theta, and this magnetic field, the experienced magnetic force is directly proportional to the angle between them. Here the current carrying wire, the small elemental area at point P is making some angle. So here the current is flowing this side. So this the angle between here, the angle is making with a small elemental area and the point P where we are keep our magnetic field. So here you can see the angle between the magnet where you are keeping at point P and the magnet field. So this is small elemental area and this is the point P where you keep the magnet. So here both the things of conducting wire makes angle theta. Here the dl and p vector force, the magnetic force experienced by at point P, that is perpendicular with each other, so they are making angle of sine theta, not a cos theta. So here the magnetic force experienced by the magnet at point P is directly proportional to the magnet product of current and the small elemental length and the sine theta between them. That means the angle between the small elemental and at point P. So the magnetic field also directly proportional to the sine theta, but it is inversely proportional to the square of the distance between the small elemental and at point, which is inversely proportional to the square of the distance between those two things. So the experienced magnetic force, it is directly proportional to I into dl and angle between them, but inversely proportional to the square of the distance between the point P and small elemental area. So we know that in order to remove the proportionality, we have introduced proportionality constant, that is K. In electric charge concept, instead of K we are substituting 1 by 4 pi epsilon naught, but in the magnetic force here experience, so the magnetic force K, in order to K we have to substitute the constant mu naught by 4 pi. So here we are going to substitute the value mu naught by 4 pi instead of K in this dP equation. So the equation become dP is equal to mu naught by 4 pi and I into dl. Here the sin theta is indicating the current carrying small elemental area, the length dl is point P. They are making some angle theta, sin theta, no, perpendicular angle. So that angle we are taking, we know that sin theta, it is nothing but the cross product. It indicating the cross product, that means perpendicular nature of dl and P with each other. So instead of sin theta, we can take that cross product and r cap divided by r square. So the equation finally become mu naught by 4 pi and the cross product of the unit vector and the current carrying wire and the small elemental length. So what these two equation is expressing, the ideal cross r cap is indicating both the things are perpendicular and force also experienced by the magnet also perpendicularly make some angle sin theta. Then so this is the final equation, and here we are going to substitute the small elemental length only we are taking. If we want to know the whole length, due to the whole length of the current carrying wire, due to the whole current which is passing flow inside the conductor, due to this whole length, how much force is exerted at point P on the magnet, that is only we need. So if you want to need that thing, means we integrate the already find out magnetic field dP. So if we taking the integral of dP, we can get the total magnetic field or total magnetic force experienced on the magnet at point P, we can easily calculate. So we are taking the integral. So integral means mu naught I by 4 by, all these things are constant because current also from the battery is constant, mu naught constant, and 4 pi also constant. Mu naught is the value we know that, and 4 into 3.14 pi is equal to 3.14 is a constant value. So the changing value is only dl, the small elemental area, because in this whole length we are taking so many different parts of small elemental area. So if you are taking this, mean angle also vary, this side means angle vary, this side mean angle vary, so the angles also vary between them, but it is perpendicular. All the elemental length are at point P, they are making sine angle, that means perpendicular angle only, they are perpendicular with each other. So dl cross r cap, so here due to this small elemental area, the force is experienced this direction and this in this direction, so r cap is also vary because the small elemental area on the whole length of the conductor also all the point. So n cap also they are varying. So we are taking the all the changing things inside of the integral. So dl vector cross r cap divided by r square. Here we are going to substitute the values cases, that is dl cross r cap is nothing but the cross product, we have take it as dl or sin theta. Instead of cross we can substitute sin theta, because dl and r both the things are perpendicular one. So if the theta, for example, in the current carrying conductor, we are taking the point P, we are keeping the magnet on the current carrying conductor. So this time there is no any angle between them. So the angle between small elemental area and at point P, theta is equal to 0. So sin theta is equal to 0 means sin 0, 0. So this equation totally is 0. So the magnetic field, when the magnet is when the point P is kept on the conducting wire, there is no any angle. That means no any forces experienced by the magnet at point P. But when we take the point P that is nearly close to that current carrying wire, but perpendicular to the small elemental length, that is making angle theta, that is they have making angle that is 90 degree because they are mutually perpendicular. So sin 90 degree, I dl sin 90 degree, that is sin 90 degree, that is 1. So after substituting this value, the equation become you can see here. So the equation become dp I dl by r square into n cap. So n cap here is indicating what direction from where to where the magnetic force is exerting, that is from dl, I into dl to r, that means point P. So from the small elemental area to length to at point P, towards the point P only, the magnetic force is exerted on this magnet. So this is the direction. There is the relation between n cap and I dl and r cap. So what is the relation between Biot-Savart law and Coulomb's law? Both the laws, they have some relation between them. Here in that electric field, it is directly proportional to charge. That means if the charge we are taking changing depending upon the value of charge we have selected, the value changes of charge q, the electric field produced by the charge also vary. The same manner here the magnetic field is vary when the current carrying, either the current flowing inside the current is vary, otherwise if the current is increasing inside the conductor, depending upon the increasing current, the magnetic field is exerted on the magnet also vary, and the magnetic field also vary. And the small elemental length, if you are taking the small elemental length is here and here and here, due to this small elemental area or the angle between the I into dl to the point P, depending upon those values, or also the magnetic field is changed. And the final thing is here the electric field and charges, they have directly proportional to charge. It is not directly proportional to square of the charge or cube of the charge. The same manner here also the current inside the conductor is vary, means magnetic field also vary, but it is not directly proportional to the power of square of the current and cube of the current is changing, means the magnetic field change is not like that. So it is not changing. So if the current is changing, if current is increasing, magnetic field is also increasing. If the current is decreasing, magnetic fields experienced by the magnet due to this current flow of decreased current also decreased. So this is the relation between Coulomb's law and Biot-Savart law. Thank you for watching.